Hi, everyone. Welcome to Asynchronous Wednesday. I'm going to give you the quick startup to get you going with class today and to help you know how to use the software for collecting data and measuring the speed of sound in class. Also going to punish you with 2 puns. All right. So a couple of question and answers for you today. I made these up myself, so they may be especially bad. Why did the lady fall down in the library? Because she was in the non-friction section. Why didn't the poet fall down in the library? Because she was contemplating her muse. Muse, yes. How amusing. All right. The plan for today, we're going to be doing a practical. You're going to be doing a practical, one of the required pieces of our course, measuring the speed of sound in your own homes. So remember, you're going to need some kind of a pipe or a tube. Today, I'm going to demonstrate using a pen because that's what I have here in my classroom. Drinking straw would probably be ideal because you're going to need to cut it to different lengths. If you have some pieces of pipe or sometimes toys will have little tubes in them. I just took the middle out of a pen, and I would be willing to sacrifice this pen by using a saw or a knife to cut it to different lengths to collect my data today. This lab isn't going to be due until December the 14th, which sounds like it's not for a while. However, there will be another practical on the refraction of light also due on that day. So do not put it off. Today is your day to do the practical. Even if you're still catching up on activities, you should set the activities aside today and make sure you devote today to collecting your data and analyzing it. This lab will be a little bit different in that you're only going to be graded on the data collection. There's no conclusion part of the lab that you're going to be graded on. So you're not going to have to do an error analysis. You're not going to have to write about, future possible experiments or sources of error. We're not doing that in this lab. You're just collecting the data table, calculations, graph, find the speed of sound. So it should be a little quicker and to the point. You should be able to get it done today. So that said, the only homework assignment you have for next class is a reading assignment to prepare you to learn about our last topic, which is light, as we finish our unit out. So let's go ahead and take a look at the lab itself. And what I would actually suggest that you do right now before I demonstrate for you how the lab is to be done, to go ahead and pause this video, go into Canvas, open up the lab handout, and read the lab handout. I'm not going to read it for you. I'm going to assume that you've already read through the theory. You already understand how an open pipe is going to produce resonance and what the different harmonics look like, and how knowing those fundamental frequencies can find the speed of sound, how the grading rubric looks. You need to read and familiarize yourself with all of that. Then come back to this video, and I'll just demonstrate a sample collection of data using Audacity. Okay. All right, you're back. Let's go ahead and tackle Audacity. So I'm going to share my screen here with you. And I'm going to open up the Audacity program. Get this going. Clear that out. Drag this kind of bigger. All right, so just this big empty gray window. I've got my tube right here. I'm just going to practice, kind of blow into it. Kind of a rumbly sound is all I'm getting. Okay, it's all you need. I'm going to hold it kind of close to the laptop so the microphone can pick it up. I'm ready. I'll click this red record button. Get it for a few seconds. Click stop. I can see there's some audio information right here. It looks like just a bunch of noise, which is all it is, just some fuzzy noise as a function of time. Now, what I'm interested in finding is the frequencies that are producing those noises here in my open pipe. So I go to the top of the screen, the Analyze option in the menu, and drop down to Plot Spectrum. Oh, almost forgot. Before I can do that, you have to select the data. So you have to kind of click and drag over the sound file itself and select that region of data you collected. Then you can go to Analyze and Plot Spectrum. And I get this kind of funny looking purple graph here, which is the spectrum of my frequencies. So down here on the horizontal axis, I see the frequencies around the threshold of hearing at 43 hertz, all the way up to ultrasonic above human hearing of 20,000 hertz. I'm getting all kinds of sounds all in there, which is why it sounds like a rumble. I get all these different frequencies happening at the same time, some very low ones, some very high ones. But notice that there are peaks or spikes, certain frequencies that stand out and are louder than others. And these peaks or spikes correspond to the various harmonics that are being produced in the pipe. Now, these harmonics are all multiples of the fundamental. So in other words, as I go from one to the next, they all get bigger by the same amount. They all jump up by the size of the fundamental. Now, one thing I noticed with this particular graph is there is an option down here for axes to go between linear and log. I think the first time I ran this, it was set up under log, which you'll see is not a linear horizontal scale, and it's just a little harder to see the spacing of the peaks. I encourage you to change it to linear frequency. That way you can see the increase in a linear manner. So you don't have to use all of this data, but what I'm asking you to do is to find 5 gaps between the peaks, because the amount the frequency goes up by, going from one harmonic to the next, should be the same as the fundamental frequency. So I need to know how far apart these two frequencies are from each other. So one neat thing about Audacity is it helps you find those peaks really nicely. You'll notice that there's this line that follows my cursor and kind of jumps from peak to peak. And then down here at the bottom, there's this box that tells me where my cursor is, what that frequency, but it also tells me where the peak is. And that's really what I'm interested in, where the peak is. So right here, if I jump up to the peak, it says D9, as interestingly, the musical note that I've got there. This frequency would be 9,148 hertz. I'm going to write that down, then I'll move over to another peak, either left or right of it, 7,821 hertz. So I'll subtract one from the other. I'll find the difference between the two peaks. That should be the fundamental frequency. You need to do this at least 5 times from this data, from 5 different sets. They should, in theory, all be the same gap size, but they're going to vary a little bit. So you can find at least 5 more if you like. Take an average and then do your max minus min over 2 to figure out what that plus or minus uncertainty is, and you'll have a frequency value from this graph. Then what you need to do is you need to repeat. Do this 4 more times for different lengths of straw or pen. So you have to cut it shorter and shorter and do it again. You should be able to then make a plot and find the speed of sound. So I will be online today working at the high school. If you need to get in contact with me, please email me. If you get stuck, I encourage you to reach out to each other as well. You need to get this lab done today. So you've got plenty of time to collect the data, create your data table, make a graph. 90 minutes should be enough to do that. The idea is then when we meet in class tomorrow, we're going to start working on light. You'll have a few minutes to ask questions, but other than that, you need to reach out to me outside of class time if you need more help on this. So try to get down as much as you can. If you get hang-ups, I'll try to troubleshoot them with you tomorrow. But good luck. This should work pretty well. I got good results when I tried this myself, and I will see you tomorrow.